Hello, my name is Primož Banovec. As a part of the team, I will present you the modeling paradigm inputs and outputs of the QUAL2K model, which was used for the WEMDST application. The QUAL2K is a well-known model for the modeling of the river and stream water quality. Basic paradigms will be shown in this very short presentation. Very short in the sense that this is quite a complex model and it is really necessary to profound your knowledge in order to understand its complexity, its functioning, but also enabling the interpretation of the modeling results. Some philosophy about the modeling. Modeling is all about knowing more and more about less and less, and basically it should be answering about two questions. What do we know about the phenomena that we didn't know before? And of course, a very important issue, how can we find out that this is true, which is very much related to the calibration and validation process. To start with the QUAL2K and its component and how it is functioning to understand it better, if we want to understand the complex phenomena, we have to segment it into smaller components. And of course, this is also true for the QUAL2K model. And the QUAL2K model, which was used for the WEMDST model application, is very much based on the segmentation scheme, where each segmented component provides a framework for the modeling of the processes inside this component. So, many components and processes together. First of those is segmentation. The next is flow balance, depth, velocity and travel time in the water course, dispersion, which is very important component, especially in the flow running water courses, temperature modeling. Temperature is extremely important because it is governing the processes, chemical processes as well as biological processes. And as well, we will see later that some other components like oxygen concentration, CO2 concentration is very much important as well. How the QUAL2K is dividing this segmentation, providing, if we are having a river reach, then we have to define the river reach in different elements, subcomponents so-called, sections. And in this case, as example, this is shown for the exemplatory process, this river reach is restructured in small components, enabling good resolution what is happening with the water quality in each one of those components. What is important, that river reach is a length of river which has similar and actually constant hydraulic characteristics. We will see later why hydraulic characteristics is important for the modeling of water quality. The segmentation is done in this way, and it was also done in the QUAL2K model for the purpose of the WEMDST, that we define the headwater boundary from the point of view of discharges as well as the background pressures of the pollutants. And of course, downstream boundary conditions are important for the hydraulics. In between, we provide point sources of the pollutions. The QUAL2K is enabling also point abstractions, as well as non-point source and non-point abstraction, but for the purpose of the WEMDST, which is aiming at the agglomerations in the Drin River Basin, point abstractions and non-point abstractions, as well as non-point pressure sources, were not modeled for the purpose of quality. So what we see here, what was modeled as a point source, the pressures from the agglomerations were modeled, and other non-point sources were not modeled. This is example. Then further on, how the segmentation and the numbering schemes is developed further on from the point of view from the main stream and tributaries, and similar segmentation was further on developed for every and each river on the Drin River Basin, rivers and their tributaries, as shown here. For example, the main Drin River and which is then going to the Ohrid Lake, sourcing here, and the other part of the Drin River, which is going to Kosovo, as well as parts of the Zeta, Morača rivers, which we see here in the Montenegro. Flow balance is one of the important components. The steady flow balance is implemented for each model. The steady flow is of course important because we, as for the purpose of the water quality modeling, we are not modeling the dynamic phenomena such as floods. During the flood events, usually the dilution is relatively high, but also beside the dilution, it is also other components. Pressures are also diluted and the phenomena is very rapid. So basically the steady flow is applicable, and we have taken the data from the discharges for the typical month of July for the steady flow calculation on the Drin River without events of significant precipitation. Steady flow balance, another example here, which is enabling the complexity for the Drin River Basin was not such. We are not having linear inflows, we are having only point inflows of the lateral streams from the Drin River, and also the reservoirs, which are quite significant in the hydraulics and of course the water quality, were modeled for that purpose, but then again with the aim of the steady flow balance. The sloping channel flow was modeled for the purpose of the water depth and the water velocity. Both water depth and water velocity are important for the water quality modeling. In the most cases, the continuity and the manning equations were applied for the purpose of the modeling. We took the data from the slopes of these rivers, which are available in the general sloping data from the topography data, where the width of the rivers were taken from the orthophoto, which means that the manning equations applied was quite simplified and in generally, of course, not applicable for the purpose of other uses, for example, as flood management. Of course, it is not applicable. This is only for understanding of the water depth and the water velocity, which is later very much related to the temperature of the water, the oxygen intake, and other processes which govern the complexity of the processes of the water quality in a water body. Hydraulic characteristics. Well, for the purpose of the modeling of the significant wear structures which occur in Albania, the hydraulic characteristics of these wear structures was inserted. The overflow was not set in as an overflow from the point of view of the oxygenation of the water body, because they are hydropower plants. So basically it was just a specific geometry data enabling the more depth and slowly flowing flow of the river, which is also having specific temperature characteristics, which means usually that the water is colder in the case of the constructed hydropower plants. So, as said before, manning equation was used for the depth velocity function identification. For that purpose, from the CHO hydraulic, which is kind of a Bible, from the hydraulic point of view, the manning roughness values were considered and inserted in the model. On the basis of this, the travel time, which is important from the point of view of the time of the reactions, in the time period where the reactions take time, chemical and biological reactions, was computed. And starting with the next component is the longitudinal dispersion. The longitudinal dispersion is beside the water flow, which is governing the kinetics of the movement of the pollutants and other substances which are modeled by the QUAL. They were in our application of the QUAL2K model based on the Fisher equations as shown here. Understanding better the dispersion phenomena, it is important that we see that dispersion is governed by the velocity. Usually the velocity is, in our cases of the Drin River, governed by the very high velocities. This is not completely the case in the case of the reservoirs and the Skadar Lake, but nevertheless in other parts of the river and their tributaries there's a quite significant component, velocity component to it, and usually we can see that dispersion impact on the phenomena is relatively low. In the case of the slow running rivers, also observing the Fisher equation before, we could observe that we could say that the dispersion coefficient is moderate or even high. In such cases, it is even possible that the kinetics of the observed phenomena propagate upstream, so it is not only downstream pollution which could occur as a phenomena. This especially could be observed in the situations of extremely low flows, such as lakes, where the dispersion phenomena should nevertheless be closely observed and modeled. The temperature model is really complex and requires a lot of data because it is actually, as shown graphically here, it is better to observe the picture down there to understand that there is an inflow of the temperature and outflow, communication of the temperature via the dispersion process, communication of the temperature with the sediment water transfer, and of course the communication with the heat load, atmospheric transfer, and heat abstraction on the surface of the water. For this purpose, the heat and anthropogenic transfer was modeled also for the Drin River and its tributaries, where we can observe that water-dependent and non-absorbed radiation was quite important, including the evaporation, based upon the external temperatures of the water. So basically quite a lot of data was inserted. As the modeling month was shown before, addressing the discharges in the month of July. July is very close to the summer solstice in Albania. So basically the daily solar radiation, as we observed here in the framework of the 24 hours, was following this upper curve, and the summer solstice and the radiation in the terms of watts per square meter as shown here. The solar radiation was also corrected based upon some other correction parameters. Basically, we did not consider that there are some clouding phenomena in this modeled in our model, and we estimated the vegetated level, the level of vegetation and the shading based upon the observation of specific river reach on the Google Maps. Of course, this is rough estimation, but nevertheless better than operating without those. So cloud cover and shade is could be relatively important, but then again, yes, clouding of course is important because it is reducing the radiation influx, while the shading is relatively more important for the smaller water courses, not really for the larger water courses, as the Drin River is in the important parts of its flow. Meteorological data are covered by this equation, so relatively quite a lot of meteorological data are required. The wind speed associated with our model, we selected that there is no wind, and also other temperatures were taken from the average month of July in the area. Sediment water heat transfer, this is relatively important because the water is the sediment has its specific temperature, and it is communicating with the water as well. So after observing some mainly components of the QUAL2K model and how we consider the equations and the parameters, we should now observe the constituents of the model. The constituents of the model are listed here, and also main three components which are then analyzed and shown and observed by the WEMDST toolbox. And in this way we understand the understanding of BOD5 and how it was taken from the slowly reacting and fast reacting BOD, nitrogen total and phosphorus total. General mass balance is relatively similar to the general temperature flux balance. Again, inflow, dispersion equations, outflow, dispersion, communication with the sediments, communication with the bottom algae. Bottom algae are really specific phenomena which are part of the modeling efforts I'm not entering too much into, but also communication with the mass load from the atmosphere, atmospheric transferent mass abstraction, which is in this dynamic equation where the general mass balance is considered as shown as time dependent. Which are important processes in the QUAL2K? Kinetic processes as dissolution, hydrolysis, oxidation, nitrification, denitrification, photosynthesis, death of the organisms, of course, and especially their respiration rate. Mass transfer processes, which we were observing before, is reaeration, settling to the bottom of the water body. Sediment oxygen demand, which could be quite tricky process in the case of the lakes or larger standing water bodies, and sediment inorganic carbon flux. So sediment is relatively important in the QUAL2K, as of course observed in all limnological models. Okay, this is quite a challenging picture to understand. So it is showing the interrelation between the kinetic processes and mass transfer processes. They are solved for each observed reach in the means of differential equations, simultaneously solved. That's why the iterative process is applied, and it's function of many components, interaction with the atmospheric data, alkalinity, temperature, available oxygen, and of course these processes are interactive as the complex of understanding of the water quality in any water body. Similar picture made in some other way. What is connected to what? For this purpose, the user should refer to the literature on limnology and water quality modeling, and more detailed description of the QUAL2K instructions. And some other insights. What is also heavily affecting the equations? The temperature effects for all first order used in the model is represented by this equation. The aeration formulas are quite important, and they are different depending on the water depth. Water depth was calculated based upon the Manning formula as seen at the beginning of my presentation. Reaeration, you can see it's also a function of the velocity and the depth, and we see which equations are governing which area of this graph. The alkalinity is quite important because it's the governing specific chemical reactions on the alkalinity, and also the related to the pH value. Again, the equilibrium of pH is also associated with the inorganic carbon concentration, as usually with the carbon bar. Carbon dioxide saturation. The QUAL2K is enabling interaction with the annual cycle of the carbon and the level of the atmospheric carbon dioxide, which is communicating with the water body. This is actually the component where some elements of the changed climate could be observed in the change dynamics of the water body. and also as shown before, the overall kinematics of the water quality. Now we can see the communication between the water and the sediments, with specific with the sediment oxygen demand and the nutrient flux model of the sediments. For the purpose of the WEMDST model, specifically the aerated part of the sediments was addressed, and the anaerobic part of the sediments was not so addressed because the water is relatively running fast, and the zone of anaerobic strata of the sediments is not that occurrent as in lakes otherwise. The ammonium concentration, very specific, important for the total nitrogen levels from the point of view of the pressures, digestions, and the communication and release in potentially also aerobic and anaerobic layers. Specifically in anaerobic layers, the nitrogen is used for the consumption by the bacteria processes. And we are closing to the end of this very short and concentrated presentation how we were using the QUAL2K model in the WEMDST model. And the solution scheme, of course, it is hidden behind. It's written in the Fortran, where the WEMDST is running the Fortran behind to provide a solution scheme. The single computation process is not, so basically it's iterative process depending on many parameters to find the solutions of equations for each specific observed river reach and its subsection. For the purpose of the modeling, we performed the calibration procedures. For that purpose, we collected data on river water quality from all participating countries, and as similar as we were using the July data on the solar radiation, temperatures and discharges, also data on the concentrations were taken for the calibration procedures. On the basis of this, we recognized necessity of some monitoring programs which should be improved. What was especially difficult for us is identification of discharges during the sampling programs, sampling procedures. So basically, the information of the current discharge during the sampling should somehow follow the sampling procedure itself. Measured data could be checked against the model data within the WEMDST tools itself. So, going to some conclusion remarks. WEMDST tool is using QUAL2K model, and it's ready for use on the website. The user should, of course, be at least slightly familiar with the complexity and limitations of the modeling tool, which equations the modeling tool is using, what are the complexity of the input parameters which enable the modeling, and this is also important for the interpretation of the modeling results. The model is calibrated for the temperature, solar flux, discharges characteristics for the month of July, which is considered as a relatively reference month. Why reference? Because the discharges are low, which means the concentrations of the pollutants are high. This is also related to the temperature and oxygen level in the water courses, which could become with significant lows also critical. Going to the interpretation of the results, it is important to understand different categories of pressures, which means how the agglomeration pressures are originating, compressing these river reaches, and also natural background and background pollution. In some instances, we have observed that there is some natural background, specifically from higher, smaller water courses, which might already be polluted with some specific old burdens or industrial activities. For further reading, absolutely recommend it to further profound your knowledge using QUAL2K technical documentation and also WEMDST project documentation, where the discussion, especially on the pressures, is given much more in detail, but also it is possible to modify any pressure using the WEMDST tool directly and see the effects of the changed pressures on the modeling results. This is quite useful to observe how the changed pressure can change the water quality. So, using the toolbox. Be brave, provide us feedback, and let us know what is your user experience. Thank you for your attention.